Hello there, ladies and gentlemen. For this video, we are going to quickly be going through a few select problems that might be giving you guys some issue. So without further ado, if you could please get out the little packet that you were given at the beginning of this unit and follow along with some of these problems, that would just be wonderful. First one is going to be from day one. We're going to go ahead and take a look at problem number 9. So problem number 9, we're dealing with a straight right triangle, so nothing too fancy. So what I'm going to do is I'm going to treat that whole x minus 1 side as one entire piece, one entire unit, one entire chunk, if you will. So if I think of this as a squared plus b squared equals c squared, I'm going to have x squared plus x minus 1 squared equals rad 5, of course, squared. Now, when we go to simplify this, x squared, pretty straightforward. X minus 1 squared, that's really x minus 1 times another x minus 1. So I could go ahead and I could do that double distribution. I'll get x squared minus 1x plus 1. After I combine my like terms, I'll get x squared minus 2x plus 1. And on the other side of the equal sign, I have a radical 5 squared. Well, a radical and a square, they'll knock each other out. I'm left with a plain old 5. So now as we look through this, the left-hand side, I have x squared and x squared. Those can combine. I get 2x squared. From that, I can subtract 2x. And generally, if I ever see an x squared and an x showing up together in the same problem, I like that to be equal to 0. Well, if I want that to be equal to 0, that means this 5 has got to go to the other side. So if I subtracted 5 from the other side, that would leave me with a minus 4. So now from here, I have an x squared, I have an x, right? So I have 2x squared minus 2x minus 4 equals 0. That tells me I'm going to need to factor. Well, if I can, I'm going to divide everything by a greatest common factor. In this case, I can divide everything by a 2. So that would leave me with x squared minus 1x minus 2 equals 0. If you don't want to write that 1, you don't have to. I like to because it helps me keep things straight. Now, if I think of this as a factoring problem, I need to find two numbers, and they need to multiply to be negative 2. So they're going to multiply to be that constant term at the end. And they need to add to be a negative 1. Some of you may have heard this nicknamed the AM method. Add to the middle, multiply to the end. The two numbers that I find that could multiply to give me 0, or sorry, multiply to negative 2 but add up to a negative 1, would be a negative 2 and a positive 1. Negative 2 plus 1 is negative 1. Negative 2 times 1 is, in fact, negative 2. All right, so the factoring's all done. Hard part's pretty much over. From here, what we have to do is figure out what our x values are. So to do this, I like to call it the cover-up method. If I cover up that first parenthesis group, that first chunk, I'm left with x plus 1 equals 0. Well, that means x would have to be negative 1. If I do that same thing, but I cover up my other parenthesis grouping, I have x minus 2, that quantity, equals 0. Therefore, x would have to equal 2. So those are my two solutions for this example. If I think way back to what this thing is even asking, is we're talking about sides of a triangle. If I have x as the length of a side of a triangle, having a negative number would not make sense at all. So negative 1 wouldn't work. That would be what's called an extraneous solution. Our answer here would be x equals 2. All right, onward. Let's see. I think most of us were feeling pretty comfortable. We went through this page in class. Let's see if we've got any difficult problems over here. We're going to be doing this quite a bit prior to the quiz that you all are taking. Let's go with an algebra review if we can find one of those. Here we go. These will be fun. All right, so let's go ahead and we'll start off with some radical stuff. I'm going to go ahead and I'm going to take a look at number 8. 5 rad 5 times 3 rad 8. So anytime I see these problems, numbers outside of the radical, in this case 5 and 3, those are allowed to interact with each other. That turns into a 15. Numbers inside the radical, 5 and 8, those are allowed to interact with each other. We would get a rad 40. From here, we'd need to go through and we'd have to make our little factor tree. Two numbers that multiply to be 40. Let's see, we got 2 and 20. That can go to 2 and 10. That can go to 2 and 5. And then we're all done. Now we're looking for pairs of numbers. Well, I'm saying that I have a pair of 2s. And I have a leftover 2 and a leftover 5. So to simplify this, I'll set up the 15 hanging out front. I can pull out a 2. And I'd be left with, let's see, if there's a 2 and a 5 left over, 2 times 5, that's 10. So final answer, we'd have 30 rad 10. Bingo, bango, bongo, we is done with that one. All right, just for fun and sunshine, let's do one of these from the day 4, just so you have a quick little recap. And then we'll call it a day. See, all these are pretty easy. I want to find a tough one. Here we go. Number 5. 5's our winner. All right, so with these problems, we have a 30, 60, 90. Even though it's not given to you, we can automatically assume that that missing angle is, in fact, 30 degrees because all of those angles would have to add up to a clean 180. If we remember our pattern, which hopefully we do, the side across from the 90 we call N, or sorry, across from the 30, my apologies, is N. The side across from the 60 is N with a rad 3 attached. And the side across from the 90, aka the hypotenuse, is the double of N, 2 times N. If we're lucky, ideally, we'll start off with the shorter leg. Unfortunately, this is not the case. So when we go through and solve these, we have to figure out what we're given. Well, I have a 60-degree angle here. They tell me the side across from that is 12. So 12 is partnered up with the N rad 3 side. Now, if I want to figure out what N is equal to, because that'll tell me my X value, what I could do is I could take N rad 3, and I know that that is 12, because that's the side length that they gave me. To solve for N, I would divide out the rad 3, so N equals 12 divided by rad 3. Of course, we don't like that, so we're going to do N equals 12 rad 3 over 3. And even that can become prettier, because 12 over 3 reduces down. We would get 4 rad 3. You could put it over 1 if you really wanted to, however, you do not have to. Cool, so we just found X. Now I know my hypotenuse is going to be twice as big as my short leg. Well, if my short leg was 4 rad 3, that means the hypotenuse has to be twice as big. So that's going to be 8 rad 3. All right, ladies and gents, that's it. That's all. So between those problems, we should have a pretty decent grasp on how to get through these missing problems, especially for this review prior to the quiz.